The A320 electrical system is quite similar to electrical systems which you are familiar with. It is simply more automatic and easier to use. There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1, Generator 2 to AC bus 2.
Each AC bus supplies its own transformer rectifier, TR. AC bus 1 to TR1. AC bus 2 to TR2. The TRs convert alternating current, AC, into direct current, DC, to supply their related DC buses, DC1 and DC2. DC bus 1 feeds the DC battery bus, DC BAT. The DC BAT bus can charge the batteries or receive power from the batteries as required. This will be further explained in the operation module. The electrical system also includes two essential buses, the AC essential bus, normally fed by AC bus 1. Note, if the AC bus 1 is lost, the AC bus 2 automatically takes over. The DC essential bus, fed by DC bus 1 via DC BAT bus.
This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator.
These three generators are all identical, and any one of them can supply the entire aircraft electrical needs. For that, a bus tie contactor, BTC logic, allows the AC buses to be supplied from only one engine generator, or only the APU generator, or an engine generator and the APU generator, or both engine generators. On the ground, the AC buses can be supplied by an external power source through the BTC logic. Note, if the APU generator and the external power are connected together to the AC buses, the external power has priority over the APU generator.
As a backup, there is a hydraulically driven emergency electrical generator, Emergen. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, located in the belly fairing, which extends in case of severe electrical or hydraulic failures.
The electrical system also has an essential transformer rectifier, essential TR. The essential TR can power the DC essential bus from the emergency generator in case of severe electrical failure, or from the AC essential bus in case of a TR1 or a TR2 failure. Note, in this case, the DC bus 1 or 2 is transferred to the DC bus 2 or 1 via the DC BAT bus. Finally, a static inverter allows part of the AC electrical network to be supplied from the battery 1 when only batteries are connected. On ground, it supplies an AC static inverter bus, and the battery 2 will supply partially the DC essential bus. In flight, it supplies also partially the AC essential bus and the battery 2, partially the DC essential bus. But the DC BAT bus is not supplied.
Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical page.
You can see that most of the components we have talked about are displayed on the ECAM page. Note: the static inverter indication will replace the external power indication only during its test and provided the essential buses are supplied by the batteries.
As shown, each component can be monitored via its indications.
These indications are voltage, current or load for the generators, frequency, and IDG temperature. You can also notice the different connections displayed via green lines. Let's now locate pilot's controls. The elect panel is located on the overhead panel. Note: the controls installed on the left-hand side will depend on the options, so refer to your documentation.
For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical page. The battery voltage can be monitored either on the overhead panel or on the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch.
The external power is also controlled by a push button. The AC Essential Feed push-button switch enables the pilots to change the supply to the AC Essential bus from AC Bus 1 to AC Bus 2. The bus type push-button switch enables the pilots to isolate one side of the system from the other. In case of failure, these push buttons enable you to disconnect an IDG from its drive shaft. The controls and indications on the emergency electrical power panel will be covered in the failure cases module, except for the emergency generator test switch. It is used by maintenance only to test the emergency generator and the static inverter. After a long stop, as the aircraft has not been electrically supplied for at least 6 hours, one of the first items to check is the status of the batteries. To check the batteries, check they are off or switch them off, and check the voltages as they are always displayed. Note, as long as the DC BAT bus is not powered, off lights on the BAT1 and BAT2 push-button switches are not lighted on, even in the off position. As you can see, both batteries are below the minimum required 25.5 volt. So, you will have to recharge the batteries from external power. The green avail light is not lighted, meaning that you have no ground power. You have to ask the ground personnel to connect a ground cart.
The ground cart is now connected. The green avail light has appeared, which means external power is plugged in, its voltage and frequency are normal, it is ready for use.
Then the battery 1 must be switched on. Note, the battery 2 off light comes on as the DC BAT bus is supplied. Then the battery 2 must be switched on. Note, the engine generator fault lights come on as they are supplied by the static inverter, which operates when both battery push-button switches are on, speed below 50 knots. As the battery voltage was below 25.5, a charging cycle of 20 minutes is required. For that, the external power push button must be momentarily pressed. So, the avail light is replaced by the blue on light, indicating the external power contactor is closed. The ECAM page has been called for you. You may confirm that the external power supplies the AC buses via the bus tie contactor, BTC logic. Also, you have to check that the battery contactors are closed and the batteries are charging. Note: battery charging is indicated by an arrow from DC BAT bus to the related battery. Now, 20 minutes are elapsed, and you should check that the battery voltage is above 25.5. For that, the battery 1 and 2 must be set to off, and the related voltage must be checked on the ELEC panel. On the ECAM ELEC page, notice the DC BAT bus indication due to both battery charge limiters not operating, with the DC BAT bus still supplied by the DC1. But, before powering electrically the aircraft, if it has been electrically supplied during the past 6 hours, the related battery voltage will be above 25.5, ensuring a battery charge above 50%. So the batteries must be switched on. Now, if the APU has to be started on battery only, make sure to start it within 30 minutes following the battery selection to on, because the charge of the batteries will be less than 25% if they still supply the aircrafts after 35 minutes. As the avail light is on, the external power push button can be momentarily pressed to supply the AC buses, as shown on the ECAM ELEC page. As the batteries are fully charged, the related battery charge limiter, BCL, has disconnected its battery as shown. It is time to start the APU. We will start the APU for you. When the APU master switch push button is set to on, the APU generator parameters are displayed and the BCL connects its battery to the DC BAT bus in order to assist the TR1 during the start of the APU, as shown after pressing on the start push button. Then, when the APU avail light is on, the APU generator is energized. Now, it is time to switch off the external power. We will do it for you. When the external power push button is momentarily pressed, with the on light on, it is replaced by the green avail light, so the external power contactor is open. This allows now the APU generator line contactor to close, shown by the related green line and by the generator load. Let's look for a moment at the outside of the aircraft to see the only item related to the electrical system during the walk-around. You should check that the external power access door is closed, if not in use. Before starting the engines, we have to check the charge of the batteries by initiating a charging cycle. For that, the ECAM elect page must be called, and both battery push-button switches must be set to off, then to on. We will do it for you. As soon as the related battery push-button switch is set back to on, the related BCL connects the battery. A battery is correctly loaded when its current drops below 60 amperes after 10 seconds and continues to decrease. If not, you must wait until the charging cycle is completed and perform this check again. Note, the charging cycle is completed when the BCL has disconnected the battery. It is now time to remove external power and to start the engines. Usually when we start the engines, the ECAM engine page is displayed. However, for training purposes only, we will keep the ECAM elect page displayed throughout the flight. We will start engine 2 first. The generator 2 fault light goes off when the generator 2 line contactor is closed. This confirms the related generator parameters are within limits. And so, the BTC logic has automatically allowed the transfer of the AC bus 2 from APU generator to the generator 2. Then, the engine 1 is started. The generator 1 fault light goes off when the generator 1 line contactor is closed. This confirms the related generator parameters are within limits. And so, the BTC logic has automatically allowed the transfer of the AC bus 1 from APU generator to the generator 1. As long as the APU generator parameters are within limits, the APU generator line contactor is kept closed. Now, as the APU is not required for takeoff, it may be shut down. Depending on the APU version, refer to your documentation. With the APU master switch push button in off selection, the APU may enter into a cooling period. So, the APU generator will stay online as long as the avail light is on. Note, when the APU is not running, the APU generator fault light is inhibited. In flight, on the ECAM elect page, you have to periodically monitor the electrical parameters and the loads. After landing, the APU has to be started. When the APU is running, the APU generator line contactor closes, provided the APU generator parameters are within limits. Then, both engines are shut down. As soon as the engine generator line contactor opens, the BTC logic allows the APU generator to maintain the supply of the related AC bus. Then, the ground card is plugged in. If its electrical parameters are within limits, They are displayed on the ECAM ELEC page, and on the ELEC panel a green avail light is on. Now, the external power can be connected to the electrical network. For that, the external power push button must be momentarily pressed. We will do it for you. When it is momentarily pressed, the avail light is replaced by the blue on light, which indicates the external power line contactor is closed. This is confirmed on the ECAM ELEC page by the green line. Note, when the external power line contactor is closed, the APU generator line contactor is automatically open. Also, the external power line contactor is kept closed as long as the external power parameters are within limits. If APU is not required, it can be shut down as shown. Then, before leaving the aircraft, the external power can be switched off as shown. Note, when only batteries are connected to the electrical network, the ECAM display units are no longer available. Then, before setting both battery push-button switches to off, make sure that the APU has been shut down at least 2 minutes before, in order to have DC power available to completely close the APU air intake flap. When the batteries are switched off, no more power is available. So, on the ELEC panel, only the battery voltage indications are still on, as they are LCDs, and directly supplied by the related battery hot bus. Also, the external power avail light will be on, as long as the ground card is plugged in, and its electrical parameters are within limits. We will now study the electrical emergency configuration. As there are a lot of events which happen at the same time in the aircraft, we will show these events in a sequential order. Let's assume we are in flight and no previous faults have occurred.
As you can see, the first consequence is that the power supply for the first officer's PFD and ND, the captain's ND, and the lower ECAM is lost. The SOP recommend in such a case that the captain will fly the aircraft while the first officer does the ECAM action. Note, another consequence is the loss of MCDUs 1 and 2.
After clearing the master lights and stopping the alarms, observe that on the emergency electrical power panel, the red RAT and emergency generator fault light is illuminated, meaning that the emergency generator is not yet online.
After a short lapse of time, the RAT and the emergency generator light disappears. The emergency generator is now running and supplying the system. Notice that with the emergency generator online, the power supply to the captain's ND has been restored. Note, MCDU1 is also recovered.
On the engine warning display, you can read that the autopilot has disengaged. Let's deal with this first. To continue the procedure, we will clear this line by pressing on the clear key.
Read the title of the failure. The red emergency configuration title means that you are in an electrical emergency configuration. The red message, Land ASAP, orders to land as soon as possible.
Observe that you have to maintain a minimum speed when the route is extended. Caution! Below this minimum speed, the route will stall, and the aircraft will only be supplied by the batteries. On batteries only, Expect to fly approximately 20 minutes.
The pilot flying will ask you to perform the ECAM actions. You will try to reset the generators. Here, this will be done for you. The reset of the generators has not been successful. Before continuing with the procedure, let's look at how to access an ECAM page when the lower ECAM is not available.
An ECAM page can be called up on the upper ECAM by pressing and holding its related system key on the ECP.
The page is displayed on the upper ECAM as long as the associated key is maintained pressed. On the ECAM electrical page, note that the emergency generator supplies the AC essential bus and, via the essential TR, the DC essential bus. As soon as the ECP push-button switch is released, the engine warning display is displayed on the upper display.
As the previous reset of the generators was not successful, we will carry on with the procedure by pressing the bus tie push-button switch.
The bus tie push-button switch in the off position segregates the two sides of the system. By doing this, a short circuit can be isolated and might give you the possibility to reset one generator. The procedure asks you to try to reset the generators again. Here, this will be done for you.
Again, the reset of the generators has not been successful. The next action will concern the ignition, as the fuel pumps are not available and so the engines are fed by gravity. We did this selection for you. Avoid negative G and apply the gravity fuel feed procedure, QRH. Then, the flight augmentation computer, FAC1, must be reset. We did it for you. This allows the recovery of the rudder trim system, but without trim position indication. And on the PFD1, the characteristic speeds, the speed protections, and the speed trend arrow. Then the bus tie push-button switch must be set back to auto. This may allow the APU generator to take over on at least one side after starting the APU. Note, the APU must be started only below flight level 250. So, the bus tie push-button switch has been set back to auto. Then below flight level 250, you may start the APU only if it is available. Note, when the APU master switch push button is set to on, the batteries are connected to the DC BAT bus for a maximum of 3 minutes. As the next step concerns another system, we will stop here and study the indications on the right side of the engine warning display. Notice the amber flight control, auto flight and air system titles. This means that these systems are affected by the boxed primary failure. Their related procedures are stacked after the current one and will appear with the completion of the primary failure procedure. For that, we have cleared the boxed primary failure for you. After clearing the affected system titles, the memo is displayed with the white STS. Again, the related key on the ECP must be pressed and held to display the status page on the ECAM upper display. As long as the STS key is kept pressed, the status page is displayed and can be reviewed. The listed inoperative systems are those seen by the ECAM. For more, refer to your documentation. Even if the rat is able to hydraulically drive the emergency generator correctly down to 125 knots, the approach speed should not be below 140 knots. Let's see what happens when the rat stalls, or when the aircraft is already on ground, with the speed below 100 knots. As soon as the rat is not able to hydraulically drive the emergency generator, the electrical network is automatically transferred to the batteries and to the static inverter. As a consequence, the DC and AC essential buses are still supplied, but they are partially shed, leading to the loss of the MD1 and the MCDU1. Note: this can be checked on the ECAM-ELEC page, if it has been selected, of course for training only. But when the aircraft is on ground and below 100 knots, the DC BAT bus is now supplied, allowing also the start of the APU, if available. On ground, if APU generator cannot be connected to the electrical network, as soon as the speed is below 50 knots, all remaining display units are lost.
We will now review some indications we did not have the opportunity to see when performing the previous procedures.
As a result of the loss of AC Bus 1 and AC Bus 2, and provided the speed is above 100 knots, the RAT is automatically extended. During the RAT extension, before the emergency generator comes online, the electrical system is powered from the batteries in the static inverter, as shown, for training only on the selected ECAM-ELEC page. Note: the approximate flight time on batteries is 20 minutes. If the RAT fails to extend, or if the emergency generator fails to be online, the red fault light on the emergency ELEC power panel will remain on, and on the engine warning display, the related procedure is displayed. Notice a new action is displayed as the emergency generator is not online. So, we did it for you. But as you can see, it is not successful. Also, the engine generator resets are not successful. As the rest of the IMA config procedure has been already studied, we cleared it in order to display the next procedure. Note: if the RAT has failed to extend, the green memo, RAT out, will be not displayed. Also, the APU, if available, can be started, but only when the aircraft is on ground and below 100 knots. Now, let's assume we are in flight. A generator overload has just occurred. Observe, on the ECAM-ELEC page, the related chain and load indications are in amber, indicating that the load is above 100% of rated output. On the ELEC panel, an amber fault light comes on, helping you to locate the push-button switch corresponding to the procedure, and in order to reduce the load on the faulty generator. So, we did the action for you. Observe, on the ECAM-ELEC page, the white galley shed appears, and the load indication has returned to normal. Note: all galley circuits, and if installed, the in-seat power and the IFE systems are not supplied. Now, let's assume we are again in flight. A smoke has been detected in the air extraction duct of the avionics ventilation system. Observe, the ECAM-ELEC page has been automatically displayed. On the engine warning display, after the ECAM actions are done, you have to refer to the QRH in order to set manually the emergency electrical configuration. On the emergency ELEC power panel, an amber smoke light comes on, helping you to locate the push-button switch corresponding to the QRH procedure. Note: here, we will see items belonging to the electrical system. When the Gen 1 line push-button switch is set to off, the generator 1 line contactor is open. This connects the AC bus 1 to the generator 2, and the fuel pumps, normally supplied by the AC bus 1, are transferred to the output of the generator 1, in order to avoid the fuel gravity feeding configuration when the emergency ELEC configuration is set. To set the emergency ELIC configuration, the RAT and emergent push button must be pressed to start the emergency generator. Then, when it is online, as shown on the ECAM ELIC page, the APU Gen and Gen 2 push button switches must be set to off. As soon as the Gen 2 push button switch is set to off, the emergency electrical configuration is set, as shown on the engine warning display, and also on the ECAM ELIC page, when it is maintained displayed on the engine warning display. So, we will stop here, as you should continue to apply the QRH, to know which part of the ECAM has to be followed. When a green circuit breaker, CB, has gripped for more than 60 seconds, an ECAM caution is triggered and indicates which panel is affected. Note, the black CBs are not monitored by the ECAM.